Good day, ladies and gentlemen. Welcome to Code Switching 2020. Today we continue with our Physical Sciences, grade 12, looking at electric circuit, question number 4. So, please pause the video, try the question, and then come and check the solution. Without any waste of time, today's question is as follows. They said the battery in the circuit has an amp of 40 volts. Switch S, which is closed, two parallel resistors of 8 ohm and 3 ohm respectively, and resistor X in series. The voltmeter reading of 25 volts. Then calculate the resistance of the parallel combination. That's number 1. Number 2, the ammeter reading. Number 3, the potential difference across resistor X. Number D, resistance of resistor X. Number E, charge that flows in 6 minutes through resistor X. Number F, heat produced in 6 minutes in resistor X. Let's look at our circuit diagram. In our circuit diagram, we are given the amp, which they said is 40 volts, the switch, which is closed, the ammeter, the resistor X, which is unknown, and the two resistors which are connected in parallel, which is 3 ohm and 8 ohm. Our voltmeter, which the value was given, which was 25 volts. Let's do question 1. Calculate the resistance of the parallel combination. We know that R parallel is given by 1 over Rp will be equals to 1 over R1 plus 1 over R2. This will be equals to R1, let's say it's 3 ohm. This will be 1 over 3 plus 1 over 8. Therefore, Rp will be equals to, you add the 2, or you can punch open brackets, 1 over 3 plus 1 over 8, all to the exponent of negative 1. Therefore, your Rp will be given by 2,18 ohm. How do we know that 3 ohm is parallel to 8 ohm? It's because of when the current enters this point, gets divided. The other one goes this side, and another one goes to 3 ohm. R parallel will be given by 2,18 ohm. Let's look at the second question. The next question, they said calculate the ammeter reading. The ammeter reading, remember that the current that enters this point, I said, will be divided into I1 and I2. Then the current that leaves this point will be equal to the total current. Mainly we can calculate the current using the voltage which they said is 12 volts. Then number B, R will be equal to V over R. Our volt, they said, is 25 over total resistor in parallel. We got 2,18. Then the ammeter reading will be equal to 11,47 amperes. Why did I use the voltage of 25? It's because of this parallel circuit. this parallel circuit will be in series with the resistor X. So the current entering this point will be the same as the current that leaves this point, will also be the current through resistor X. That's number B. Therefore, the ammeter reading, which is the total current, will be equal to 11,47. Let's look at question C. On C, they said calculate the potential difference across resistor X. So for us to get the potential difference across resistor X, solution for C, remember that when two resistors are connected in series, this is V1, this is V2. So meaning the total voltage will be equal to V1 plus V2. So since we are given the voltage, which they said is 25, then we can say the voltage that will go through resistor X will be equal to V through resistor X will be equal to the total voltage, which was 40 minus 25. Then the voltage through resistor X will be equal to 15 volts. The potential difference through X will be equal to 15 volts. Number D, they said calculate the resistance of resistor X. The resistance will be given by the voltage over the current. The voltage which we just calculated, we got 15 divided by the current. What was the value of the current? The value of the current was the same current, which was 11,47. This will be 15 divided by 11,47. 15 divided by 11,47, we got 1,31 ohm. Therefore, the resistance of resistor X, Rx, will be 1,31 ohm. Next question, number E. Calculate the charge that flows in 6 minutes through resistor X. We know that the equation for a charge is Q is given by IT. The time they said is 6 minutes. We must calculate the charge in seconds, meaning T will be equal to 6 multiplied by 60, which is 360. I is the current that flows through resistor X. Our current was 11,47, time which is 360 seconds. Then the charge that flows will be 11,47 multiplied by 360, which is 4,129,2 coulomb. That will be our charge. The last question. Calculate the heat produced in 6 minutes in resistor X. F, the heat is the same as the energy, which is W equal to I squared RT. I squared is the current through resistor X. R is the value of the resistor. T is the time in seconds. The current through resistor X we calculated, we got 11,47. The resistor was 1,31 and the time in seconds is 360. Then the heat produced is 62,044,12 joules. That will be all for today. Thank you for watching. For more videos, please go to Code Switching 2020.